Welcome. Let's take a look at the slope for parallel and perpendicular lines. And this is where you need to remember that if two lines are parallel, the slope is the same. And if they're perpendicular, you use the opposite reciprocal. Let's take as an example this one here. If we change it around to slope-intercept form, we can find the slope of it. So I'm going to subtract 4x from both sides, and I get 2y equals negative 4x plus 6,148. And now I'll divide by 2. So we get that y is equal to negative 2x plus whatever this is, just doesn't matter because all we're looking for is that slope. And that means if you're looking for a line that's parallel, you're going to use the slope of negative 2. If you're looking for a line that is perpendicular, you're going to use the slope of 1/2. So it's either negative 2 or 1/2. Let's go ahead and do a problem where we find both parallel and perpendicular. So I'm going to cut this in half here. And on this side, this side will be my parallel side. And this will be my perpendicular side. And the first thing that we need to do is find the slope of this. So we will move the x over. I'm going to subtract x from both of them sides. And I have a negative 3y is equal to negative x minus this 18. I'm going to now divide by negative 3. So I get y is equal to x over 3 plus 6. Now, this is x over 3, which can be written as 1/3 x. And it's much better to write it this way because you can very clearly see the slope now. Okay? So that means if you're looking for parallel lines, first we're going to do parallel over here. That means the slope we're going to use is the one that's exactly the same. But when we do the perpendicular line, we're going to use the slope that's the opposite sign and the reciprocal, which is 3. Now, yes, 1/3 does become 3 over 1, but you don't need to use the 1, so we just have 3. And in this case, negative 3 because it's the opposite reciprocal. So that gives us the slopes we'll use. Let's start over here with the parallel line. And so I have y equals mx plus b. And I'm going to use this point with its x and its y. The y is 5, so I'll say 5 is equal to 1/3 times negative 4, which is the x, plus b. Now we can continue to work to solve for the b. So a negative times a positive will get a negative. 4 times 1 is 4 over 3 plus b. So now we can do 1 1/3, or we can leave it at 4/3. It's choice here. I'm going to add 4/3 to both sides. And so here we have 5 plus 4 over 3 equals b. Now, the classic way to handle fractions is to make the 5 be a fraction over 3, which would make it 15 over 3, multiply top and bottom by 3, plus 4 over 3, and that gives us 19 over 3, which we could write then as 6 and 1/3. The other way that we can do it is see that as 5 plus 1 and 1/3. So the 5 plus 1 is 6, and it's 1/3. Either way, we would get 6 and 1/3. So that means our equation is y equals 1/3 x plus either 19 over 3 or 6 1/3. Your choice. Since I have this other one set in fraction as 1/3, I'm going to keep it 19 over 3 this time. And my personal preference is usually to keep a fraction as an improper number because it's more useful in calculating in problems to do that. So this is the equation if you are looking for parallel lines. So that line is parallel to this one. Now for perpendicular, we're going to do the same type of thing, but we're going to use this slope. Now we can do y equals mx plus b, but the other way that you can get the equation is to use the point slope form and work it all out, and it'll get y equals mx plus b. I'm going to try this one this time. So the point slope form is doing y minus y sub 1 equals slope times x minus x sub 1. And here's my x and y over here, and it's the only one, so it is my ones. And so that means it's going to be y minus 5 equals negative 3 times x minus a negative 4, which makes that plus 4. And now I will multiply the negative 3 to, as distributive property, gives me negative 3x, and minus times plus is minus, so it's 3 times 4 is 12. Now I'm going to add 5 to both sides, and I get y is equal to negative 3x minus 7. Now this is one of those types of problems where you could do it either way. You could use y equals mx plus b and solve for the y-intercept, or you can do the point slope form and work it all out, and it will give you the correct form. And you could do it either way and can switch these, and it doesn't matter. You're going to get the same answer. But this one is the perpendicular equation to this line here. So here it's the same exact thing underneath, it's just practice. So let's do that as practice. Put that there, and I'll make this the parallel side and this the perpendicular side. But the first thing that we need to do is to find the slope here. So I'm going to subtract 7x from both sides. So I have negative 2y equals negative 7x plus 3. And then I'm going to divide by the negative 2. So I get y is equal to, oh, that's positive. So 7 over 2. And it doesn't matter here. That's negative 3/7. We just don't need that. What we need is this. So it's y equals 7 over 2x. So that means here the slope is going to be 7 over 2. And here the slope is going to be negative 2 over 7. So I should put m equals, actually. Let's go like this and make that a little neater. That I'm going to say m is equal to negative 2 over 7. So now we'll use, this time I'll reverse the steps, although it doesn't really matter here. This time I'll do the point slope form here. Y minus y1 equals the slope times x minus x1. So that's y minus a negative 1 makes this a plus. So y plus 1 is equal to, the slope is 7 over 2, and it's 4. Oops, it's x first. X minus that 4. Make that 2 clearer. In fact, I'm going to write that 7 over 2 overall a lot clearer. So that's the point slope form. Now I'm going to multiply it out and multiply 7 over 2 times both of those. And 7 over 2 times 4, the 2 goes into the 4 twice. So we have 7 over 2 times the 4. 2 goes into that twice, so 7 times 2 is 14. And then I'm going to subtract 1 on both sides. Y is equal to 7 over 2x minus 15. So there we are with parallel. Okay. And now on the other one, I'm going to do the same type of thing, but this time I'll use the y equals mx plus b. So I have y equals negative 2 over 7 x plus b. And let's put in the y and the x. So we have negative 1 equals negative 2 over 7 times the 4 plus b. Negative 1 equals negative 8 over 7 plus b. Let's add that to both sides. So it's negative 1 plus 8 over 7 plus b. Ooh, boy. So a couple of ways to do this. I'm actually most comfortable with changing this to negative 7 over 7 plus 8 over 7 plus b, because 7 over 7 is the same as 1. So we have 8 take away 7. That gives us 1/7 is equal to b. You could do this where it was 1 and 1/7 minus a 1. So that would be another way to look at it. In fact, let's set that up here. To do it as negative 1 plus 1 and 1/7 E is equal to b. So 1 and 1/7 take away 1 would be 1/7. Okay, that's an acceptable way too. Either way, what we get is that y is equal to negative 2 over 7 x plus 1 over 7. And this is the type of problem where, because if you divide by 7, you end up with a never-ending and never-repeating decimal, that you need to leave it in fraction form so it's a more exact answer and doesn't need to be rounded. One last thing to mention here. What was it? Yes. In this problem up here, I made the point that we could do either of those, but I want to make a point about slope. Slope is never a mixed number. So say you get a slope where it's 9 over 5. We could write that as 1 4/5. That is not acceptable to put in y equals mx plus b. Because when you put it in this form and you put an m, you put the number for the m, that is actually seen as the rise over the run, which you can't do that way. You can't do using a mixed number. You would have to change it back to an improper number. The only saving thing you could do with this one would be, it would be okay if you made it a decimal as 1.8. That's okay. Decimal is okay, not a mixed number. So this is okay. This is okay, but not okay here as a mixed number. So the 1 4/5 would not have been acceptable. So just remember that about slopes. All right, now you should be comfortable with parallel and perpendicular slopes and therefore equations. And that is what, there are other things, of course, in every section to know, but this is the priority to focus on here in this section.